Hi there, and welcome to another Tech Tips Tuesday. In this episode, we're going to take a look at solder, and we're going to determine which solder is the best for you. So what we're going to do is we're going to look at the diameter of the solder and what they put in the solder, what kind of flux they're using, what's safe to use, and what isn't safe to use for electronics. So let's just get right into the video. Here's a bunch of solder that I use on a regular basis. And yes, I do pronounce the L in solder. So if you're standing in a store and you're staring at a whole bunch of solder on a shelf and you're thinking to yourself, oh man, there's such a huge selection here, what do I choose? Well, you're not alone. A lot of people get confused with this because there really is quite a selection of what to use, and a lot of people make a mistake that's really quite common, and this is one of the mistakes right here, and I'll tell you about that here quite shortly. So really, to make this nice and short and sweet, if you like to work on, say, guitar amplifiers that are point-to-point wired, so vacuum tube equipment where you have exposed pins on the bottom of a chassis, if you like to work on through-hole circuit boards, and you might be able to get away with doing some surface mount work, the best diameter to use is a .032. This is kind of a middle of the road. If you wanted to play it safe, you'll be feeding more of this stuff in there, but a .020 is definitely safe for working on surface mount equipment. You'll be able to do the surface mount stuff quite easily with this. If you're working on circuit boards, just regular through-hole circuit boards, .020 will work just fine. But if you're going to be working on chassis, with a point-to-point wiring, say vacuum tube equipment, this is verging just a little bit too thin. You're going to be feeding a lot of solder in there, and you'll probably go through a little bit more solder that way. So .032, I find, is a nice middle-of-the-road diameter solder to be using for pretty much everything. As I say, when you get down to surface mount work, if you're doing sizes that are 0603 and 1206 and stuff like that, you'll probably get away with this. I should say 0603, 0805 to 1206. You'll probably get away with this. If you're going to start to go down to 0402, at that point, of course, you're wetting the tip of your iron, and you're just basically using what's on the tip of your iron with some external flux. And I'll touch on that here in just a little bit. Another thing to be very leery of is what's inside the solder. You have to know what's inside it. You can't be using acid core flux or acid core flux paste, like the stuff they use for plumbing, soldering, and stuff like that, for anything that's electronic, because it'll just basically corrode the traces right off the circuit board and take tinning off. So you have to be very, very careful of what's inside your solder. Now, the three basic flux or rosin cores that you will find in a solder is type R, type RA, and type RMA. All right, so type R would be the weakest. All right, that's basically just rosin, and there's absolutely no activators inside it. So you need a very, very clean surface for just a type R flux. So if it said flux and then it would just have a little R there, that would mean that there is no activation in it. All right. So the next one up that's a little bit more aggressive than an R would be an RMA, which means rosin mildly activated. So this is for pretty much working on nice clean circuit boards. If you've cleaned the surface area and everything just fine, you'll get away with an RMA flux. And most RMAs are a no clean. You don't have to worry about it. You can leave the residue behind. You always want to check with the manufacturer's data sheet on the solder to see if that's okay, but most RMA type fluxes are absolutely fine to leave on the circuit board after you've done your soldering. The next one up is type RA flux, and that's the stuff that I prefer to use. I get it in liquid form and I fill it in a bottle, and I'll even use it when I'm using an RMA flux or a solder with an RMA on the inside. So what I do is if I'm working on circuit boards, I usually put just a little squirt of this RA flux on there when I'm resoldering or doing anything like that, and it makes the soldering quite a bit nicer. Now, you'll find that, solder that sits on the end of your iron, it kind of goes dead. There's nothing in it. And that's really because it's boiled off all of the fluxes inside the actual solder. So if you put a bit of a dab of RA type flux on what you're working on, again, usually it'll kind of reactivate that solder. But anything that's been sitting on the tip of your iron, chances are there's burnt flux in it and it's going black, or it gets dark. So you should really clean that off of the tip of your iron before you go in and do any kind of soldering. So basically you want a nice clean tip that's just tinned. So I find that these little, it's kind of like an abrasive material. It's almost like shavings that they put, like a scouring pad, a metal scouring pad. And they work very, very well for cleaning the tip of an iron. As you can see, my sponge is dried up over here. It dries up really, really fast. This place is very dry. It pulls all the moisture out of these sponges right now. But I also find that if you use the sponge with a soldering iron tip, it does lessen the life of the tip. And the reason that it does that is because if you have water or a cold substance on that sponge and you have a blazing hot soldering iron tip, which even for just regular soldering use is really, really hot, when you touch that really hot soldering iron tip to that wet sponge, there's a really, really fast temperature difference there. And sometimes that causes the tips to deplate after a while. So I find that the abrasive pad, stuck inside of a little holder, you can buy them like this, and then you just you kind of poke your soldering iron in there a few times, and the shavings, they scrape all the crap off. You find that you get a little bit longer tip life than using a wetted sponge. So there's another little tip there for you. Years and years of soldering and replacing countless number of tips. I also went to a Heiko machine. I really like Heiko products. Their tips seem to last the longest out of all of the other manufacturers, at least that I've tried. And I don't want to be mentioning any other kinds of manufacturers, but there are a lot of very common soldering irons on the market. And the Heiko it seems to last the longest out of them. And that's why I changed to a Heiko. I very, very rarely have to change tips on my iron due to them decaying or the plating going away. I do change tips on the iron just depending on the kind of soldering work I'm doing. Of course, if I'm soldering vacuum tube gear, I want a bit of a chisel tip. And if I'm doing surface mount work, I use a hooked tip, a very small hook tip, and that works very, very well. In fact, I can probably grab, and that one's got solder on it still. So let me see. Do I have another tip here I can show you the little hook? Unfortunately, I do. I do have a hook tip right here, so I'll just reach into my bag of various different tips. I have all sorts of different tips, as you can see in this bag here. All these different tips are just for different use. And if you're doing any kind of surface mount work, this tip right here is by far the nicest to use. Get it to focus on that. Come on, you can do it. There you go. So there is the tip right there. This is very, very nice for surface mount work. And of course, whenever you're doing surface mount work, basically you're wetting the tip and then putting some RA flux on the actual board. And what happens is the component on the circuit board wicks up the solder. And I'll do an actual surface mount reworking tutorial here in the very near future. So there's a few ideas for you using different solders. This one here, 0.015 diameter, is very comfortable for 0402 work. It doesn't, you don't put too much on it. It's a 6337. It seems to be the common now, so 63% tin and 37% lead. I do have some 6040 solder, and this stuff is made by YIKST, and I've used this stuff for a while, and it looks nice when you solder it, and it works very, very well. If you take a look at any of the surface mount circuit boards that I use, I try to use this solder on it because basically when you're done, the little solder balls on the circuit board, they almost look like polished chrome. So this is very nice for that, especially if you're going to have an exposed circuit board that you're going to show people or anything like that. I really like this solder. Now, I'm all out of the bigger diameter of it now because I use it very often. And this is also very good for vacuum tube equipment as well. Again, I have some RA type flux in a bottle, and that's very handy for just dispensing. This is an ink bottle, and I dispense this on the joints that I'm going to be soldering. Works very, very well to add just a little bit of extra flux there. I clean off my flux off of circuit boards and everything with either acetone or lacquer thinner. So I find that acetone works very, very well to get the flux off. And lacquer thinner, I find, also works very, very well. The lacquer thinner is a little bit different. It doesn't leave streaking on circuit boards that you make at home. You'll find that the acetone will make streaking. If you use alcohol, you will get white streaking all over the place. So I guess in order, it would be alcohol, acetone, and then lacquer thinner. Lacquer thinner, of course, leaving the cleanest product. Of course, acetone and lacquer thinner are vapor harmful, and you want to be careful around that stuff. You don't want to be breathing the fumes. It's pretty intoxicating, that stuff. If you're ever working on anything with a ceramic substrate, so to give you an example, we have a BMW X5, and it has Bosch electronics in it, and the dynamic stability control module went haywire in it, and it has a ceramic substrate with basically an open die. So the processors are all open, and the bonding wires, you can see them, they run right into the ICs, and they have a jelly over top of them. So I split the cap open on there, and I went right down to the actual ceramic substrate on the bottom, and I had to reattach some bonding wires under the microscope. And of course, that brought the $2,000 module back to life about 4 years ago, and it's still working just fine. So whenever you're working on a ceramic a substrate or anything like that, you'll find that the traces on them are usually a silver. And you have to be very, very careful. You want solder with silver in it whenever you're going to be soldering any kind of ceramic substrate. Because if you don't, what'll happen is when you touch your soldering iron to the ceramic substrate, it will migrate the actual silver from the substrate onto your soldering iron tip, and you'll be left with no trace. So you want to be very, very careful with that. So if you're going to ever work on any kind of a ceramic substrate, always use, this is a lead-free solder, this is tin and silver. And I find that this works quite well, and I don't get any migration issues. Of course, dwell time with your soldering iron is a very important thing to know. You don't want to keep your soldering iron on that substrate for a very long time. Now, there's a couple of tricks to that as well. If you're working on a ceramic substrate, you'll find that it'll very, very quickly suck the heat right off of the tip of your soldering iron. So you got to be careful with that. So you have to have your soldering iron working relatively hot, and you have to keep the dwell time very, very short. So yeah, so that's one thing to keep in mind. I've worked on all sorts of different types of ceramic substrates and stuff like that, and really it's a bit of an art to it. So if you ever get a chance to work on it, you'll see what I mean. Or if you have some old device with a ceramic substrate in it, you can practice on an old device if you think that you're going to be doing that in the future. So this solder with a red label on it has a red label for a reason, and it's called organic core solder. And a lot of people think that, oh, it's organic core, and it says it's water soluble. So, you know, this is they think that this is the really safe stuff. Absolutely incorrect. Organic core solder is very, very aggressive. It is one of the most aggressive cores inside of a solder. If you leave this organic core, the actual residue from the inside of the solder, on anything that's tinned, it will remove tin within hours. It will just absolutely destroy circuit boards. So you need to absolutely 100% wash all of the actual the flux material off of it. This here, see, it says water soluble rework flux. If you put this stuff on tin and leave it for just a few hours, it will take the tin right off. It'll just absolutely, it's very, very aggressive flux. So if you are going to use, if you're making your own circuit boards, I don't suggest that you use an organic core solder. If you are working on a circuit board that, say, has a lot of damage to it, and it's really hard to work on, say, maybe the copper or the traces are very oxidized, that's where this is where this stuff kind of shines, because it is a very aggressive core. But once you're finished working on it, you need to make absolute 100% sure that you get all of this flux right off of the board. If you don't get it off of the board, your soldering connections will probably open within a month if you leave any kind of amount on it. Very, very aggressive solder. Great stuff if you have hard to work on or very oxidized traces and very, very bad condition circuit board. Absolutely great stuff to use, but again, you just have to make sure that you get rid of everything. So if you have a roll of solder and say the labels are peeled off and you don't know what kind of solder it is, one very easy way to tell is this stuff here, when you melt it on a soldering iron tip, if you have this organic coarse solder, it smells a lot like hot transmission fluid. So if you have a solder, when you're soldering it, I'm not telling you to inhale the fumes because, this stuff is vapor harmful. So, you got to be careful. But the scent of the flux residue when it's burning on a tip smells really, really close to very hot transmission fluid. So again, don't be inhaling this stuff though. You want to be very, very careful. This stuff is vapor harmful, and they tell you that right on here. Caution, vapor harmful. So you want to be very, very careful. For industrial use only, it says. This stuff here is basically this stuff in a pen. So you can buy this stuff, this rosin flux pen, and these are, relatively expensive. If you were to buy a bunch of these things, you could just buy a big bottle of this stuff and put it in an ink bottle like I do. An ink bottle like this with the way I solder will last me a very, very long time. These things you'll find that you go through very easily. And really what it is just a little pen tip on the end, and then you press this down on the circuit board, and this has got a little valve in it that will allow the flux to flow out onto this tip, and you can brush this onto circuit boards if you want to use a lesser amount. I have to warn you about these pens though. Many times I've purchased these pens, and when you push down to dispense the flux, it almost shoots out. So you got to be very, very quick or very, very easy with dispensing the flux out of these pens, and that's how most of these pens work. So you give them a bit of a press on the circuit board, and then it releases the flux onto the tip of the pen there. So that really is all of the solders here, and a quick explanation of what to really choose. So just quickly again, if you want a general kind of solder that will almost work for everything, 0.032 diameter, 6337 with an RMA flux works very, very well. So, and to recap quickly again, if you're going to start doing a little bit more, if you're not going to be really doing any kind of chassis mount point-to-point work, if you're just going to be doing surface mount and through-hole work, 0.020 will work just fine. Where this falls off again is when you're working on point-to-point equipment like vacuum tube gear. That's when you want to, have the 0.032. So in my own opinion, the 0.032 is just really a happy medium for for an everyday kind of solder. A quick little bonus tip for this Tuesday: hot glue removal. So what I'm going to do is I'm going to take my hot glue gun here, and I'm just going to be crazy, and I'm going to hot glue some wires right to my bench surface. This is industrial hot glue, and it is sticky. The bench surface is roughed up. So if there's anything that this is going to stick to, and it's going to stick to really bad, it will be this surface. So what I'm going to do is I'm just going to let this harden up, and I'll be right back and I'll show you how to remove it. Alright, this hot glue is stuck to the surface, and as you can see, I'm moving my bench really with this right now. It's that stuck to the surface. This hot glue is really, really tough stuff. So the way to get rid of this is very, very simple. If you want to remove hot glue from a surface, all you do is you take 99% rubbing alcohol and put just a little bit on the hot glue and just let it sit for just a moment. You're probably thinking, if the surface is agitated, it would stick that much worse. If it was roughed up, it would stick that much worse. So this surface is pretty rough. And believe it or not, when the surface is rough, like it's got scoring from sandpaper on it, the hot glue sticks really good. But when you put the rubbing alcohol on, it releases it even easier because the actual rubbing alcohol gets into those little grooves and goes right underneath the hot glue. So when a hot glue has been sitting in rubbing alcohol for just a little bit, all you got to do is work at the edge. Now I've already got this coming off at the edge with just my finger. Let's see if I can do it without using any tools. See, here we go. Just like that. That's how easy hot glue comes off with rubbing alcohol. Now if you leave rubbing alcohol on the surface of the actual hot glue itself, I'll try and do this around my tripod without bumping it. There's some alcohol on the surface of my bench here. I'll put a little bit more on here. If you keep working at the actual surface, look at that, absolutely clean, no hot glue on there whatsoever. It just it doesn't really melt the stuff, but it completely just releases it from whatever it's held to. Of course, if this was going to be stuck to some form of a cloth wire or something like that, I would imagine it would probably be a little bit tougher to get off. But, you know, of course, the rubbing alcohol is going to soak right into the cloth wire as well and probably release it just as well. I haven't actually tried with a cloth wire, but so if you've got any kind of hot glue on a surface inside of any of your equipment, or I like to use this hot glue just to temporarily hold things sometimes while I'm working on something, just a little bit of alcohol and the hot glue just completely releases. It just comes right off. Hope you found these tips useful today. If you did, you can let me know by giving me a big thumbs up and hang around. There'll be many more Tech Tips Tuesdays just like this, touching on all sorts of different topics. Right now, I'm in the middle of working on a really lengthy restoration video, so hopefully I will have that up here pretty soon as well. So until next time, bye for now.